back in the late 1980s, early 1990s, there was a growing number of different diagramming languages. It seemed like most realized, step into a whiteboard or drawing a diagram can help explain either the analysis of a system, the design of a system, the different components, but nobody had really figured out a consistent diagramming system. So different textbooks and you'd have their own diagrams. What did an oval mean? What did a line mean? What did a dashed line mean? What are different arrowheads? What's a rectangle mean? They had different notations, sometimes different concepts, and so it wasn't clear. In the mid-90s, though, Booch, Jacobson, and Rumbaugh got together and came up with the unified modeling language. And this language has a bunch of different diagrams, and it can be used pretty casually or pretty formally. But basically, over the years, it's become the standard. So now diagrams of software systems are typically one or more of these diagrams. Our focus here in CS200 is that you're able to recognize 4 of them and understand what they're showing, basically what you're showing. So we're not asking you to design or create these yourselves yet, but just if you see these, kind of recognize what aspects of a system are being shown. First of all, use case diagram. Use case diagram is basically a context diagram, a way of looking at the whole system. In this diagram, the minesweeper is the system we're building, and actors are external to the system and use or interact with the system. So this is showing an external actor we've named player, can configure the size of the map, choose locations, choose to play again. So different actions they can do with the system. So use cases are typically verb phrases, and they're shown in ovals. Okay, and so this diagram is behavior. This diagram you could possibly imagine could be the beginning of a user guide, or someone that's anticipating on testing will think, okay, can start planning test cases, because these are test cases the system essentially must pass. Use cases become test cases. Does the system do this? So that's briefly about use case diagrams. Class diagram. So there's like an individual class shown here, or multiple classes with relationships. So basically a class is shown with a rectangle with sharp corners, not rounded corners. And it's typically shown with it's got to have at least one compartment with the name, typically uppercase. I think it's required in UML to be uppercase first letter, and at least one compartment. But as you can see here, there's 4 compartments. Typically the second compartment is attributes. So at a conceptual level, they'd just be descriptions of attributes of whatever the class is. As you work through details of the system you're designing, frequently these will become actual data values. And we're showing the notation, the data types as Java format. It doesn't have to be. There's a more general way. But if you know the language you're going to be using, then it's acceptable to just use language specific here. So in the attributes, the second compartment, you can notice some of the minus signs mean private. The underlined, that's a class method. The other are class attribute. These others are instance attributes. Okay. In the third compartment, it has operations. We can think of those as method headers. How users will interact with the with instances of the fruit class. And note the constructors. This is again Java specific notation, because in Java the name of a constructor is the name of the class, but other languages you might just say init, and how to initialize an instance. The plus means public, and the underlying num instances, that means it's a class method. Okay. The last compartment, responsibilities, basically is an overview of what this class does in a system. Typically this is one of many classes in a static view of a system, each class has its own responsibilities. And so as we're adding functionality to existing classes, the responsibilities help guide us about what functionality goes in which class. So this is briefly on an individual class. Class diagram typically has multiple classes. All the details may not be shown. It may be as simple as object, or have some details like circle and some relationships between them. The arrow between object and circle is showing that circle inherits from object, or circle specializes object. So circle is an object plus additional detail, additional specialization. The shapes to circle manages line, essentially that's aggregation. So shapes has 0 or more instances of circle, or more specifically, an instance of shapes has 0 or more, manages 0 or more instances of circle. And so we can have class diagrams to show structure of a system, and this is independent of time. It's overall structure of a system. An object diagram is instances of classes. So notice that circle is underlined. That's key. We can see there's a specific name, C1:circle. So this is an instance of the class circle. Instances typically have attribute values, and whether you show them or not is whether it's useful to. These are kind of like a map, an abstraction, where we're trying to pick out the salient or most important aspects of something to convey some idea. We can imagine this is showing that in a paint program, at some moment in time, we should be able to have a couple instances of circles with different radiuses and a rectangle that a user has created in our shapes program. That sort of idea. Okay, so key features, these are rectangles, but the name is underlined, indicating these are objects or instances of classes. Here's a simple activity diagram. These can be at different levels, from high-level concepts down to basically code. And basically it's been around, this sort of diagram has been, control flow diagrams have been around a long time. When it was incorporated into the UML, they added some things and called it an activity diagram. The basic idea is you start at the starting dot bullet point, and then there's rounded rectangles, and these are activities that you do them until they're done. And when you're done, you follow the arrow, and then you do that until it's done, and then you reach essentially a decision, and the conditions leaving on the branches tell us which path to take. And so this one is branching back, essentially showing a potentially repeating sequence. Eventually you get to the target symbol, and that's the end. And so these show basically some behavior, the flow of control through a system. Here's a few resources to read about it. Wiki page, bunch of diagrams. There's a lot of details, and here's a simple drawing tool. There's other tools that can switch back and forth between code and diagrams. So you can do some code, come up with a diagram, or start with a diagram and develop code. But here's a simple one that was used to create some of the diagrams in this discussion.